To build AI software right now, most developers write a prompt, wrap it in a basic API, and call it a day. But when you put that kind of fragile application into a real, high-stakes enterprise environment, it completely collapses. By 2026, the technical requirements have changed. It is no longer enough to generate a coherent chat response. Businesses now require systems that take an ambiguous goal, break it down into actionable pieces, and independently execute the resulting workflow. When a basic chatbot tries to handle those kinds of complex multi-step processes, the failure cascade is predictable. The context window fills up, the model loses the plot, hallucinations corrupt the output, and any automated actions taken without an audit trail immediately violate strict compliance frameworks like the EU AI Act. This chart shows the projected workforce demand across AI disciplines. Notice how the market for basic prompt engineering is flatlining. Meanwhile, the demand for engineers who can actually build secure, multi-agent architectures and Kubernetes AI platforms is scaling aggressively. Stacking more APIs together won't fix the underlying fragility. Surviving this market shift requires moving beyond simple text prompts to master the engineering of autonomous reliability. This diagram shows the architecture of a complete sovereign, enterprise-grade autonomous AI platform. This is the 100th and final lab in our curriculum. It operates across 6 distinct layers, from the user interface down to bare metal deployment. If we pull this apart to look inside, we can see how the system handles incoming requests. Instead of waiting for a human to guide it step by step, the platform autonomously decomposes enterprise tasks and routes the resulting subtasks to the correct internal systems. That routing happens here, in the agent layer. By using LangGraph, we replace static, linear code with stateful execution. If a process fails, the logic loops back, assesses the error, and dynamically attempts a new path until the task is complete. But reasoning loops need accurate context to make good decisions. In the knowledge layer, enterprise documents are chunked and processed through retrieval-augmented generation. We use PostgreSQL to manage the structured data, while Qdran handles the complex vector searches that feed exact, relevant facts directly into the active agents. To keep the model from losing its place during long operations, the system relies on Redis. It records the exact state of every active node, bridging the gap between an LLM's highly constrained short-term context window and true long-term memory persistence. An AI without stateful routing and persistent memory is a calculator. When you integrate these layers, you build an independent reasoning engine. A reasoning engine isolated in a vacuum is highly intelligent, but it lacks the ability to reach out and touch your actual enterprise data. This diagram shows the Model Context Protocol, or MCP. It acts as a standardized bridge. Instead of writing fragile custom scripts, MCP gives your agents secure, standardized read and write access to local file systems, external APIs, and active databases. However, if you give a single monolithic agent access to all those tools and ask it to research, plan, and execute simultaneously, the cognitive load will cause it to fail. The solution is a multi-agent system. The workload is distributed across specialized nodes, a planner to sequence the steps, a researcher to gather evidence, an execution agent to run the tools, and a reviewer to verify the logic. Because they are independent, we can design consensus mechanisms. These agents debate their findings, check each other's math, and self-correct their errors before a final action is ever taken.
True system reliability doesn't come from fine-tuning one perfect language model. It comes from engineering a collaborative network of specialized, self-checking agents. Deploying an autonomous swarm into an enterprise network without rigid oversight exposes the system to prompt injections, massive data leakage, and immediate compliance failures. This schematic shows the security layer enforcing role-based access control. It protects the multi-agent swarm by blocking unauthorized requests while simultaneously writing every internal action into an immutable audit log. Above that sits the observability layer. By integrating OpenTelemetry and Prometheus, the system traces the exact logic path an agent took to reach a specific decision, documenting the intermediate reasoning steps that are usually hidden. Under legal frameworks like the EU AI Act, automated systems cannot act unchecked. We enforce this through human-in-the-loop approval gates. The system pauses the entire workflow just before execution, waiting for an authorized human to review the audit trail and manually authorize the final action. An AI deployment only becomes legally viable and enterprise-ready when its reasoning is fully observable, securely auditable, and subject to an absolute human veto. When you host these layers on your own hardware, you achieve data sovereignty. You secure complete operational control over your enterprise data, entirely free from the limitations and shifting terms of black box API vendors. The Agentic AI Mastery course provides the exact curriculum to reach that operational independence. It starts with your local environment setup in Lab 1 and systematically builds up to complex retrieval systems and multi-tool MCP architectures. Every step uses a zero-failure framework. We use strict granular navigation rules, safety nets, and rollback procedures so that you successfully implement the technology at every stage across all 100 labs. The curriculum culminates in a massive final capstone. You will take the multi-agent swarm you've built, containerize the agents with Docker, and push them into production by deploying local models using Kubernetes, Argo CD, and VLLM. The open-source tools required to build autonomous infrastructure are freely available right now, but mastering them takes the discipline of this exact roadmap.